Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today's discussion is going to be centered around the group 3 elements, and of course we are going to look at one of the members of this group elements, which is the first member of boron. And our last discussion had mentioned that basically boron, unlike other elements which are going to display metallic character, is going to be a unique element that is going to be exclusively displaying non-metallic character both in its physical and chemical properties. Now, in this specific sense, then therefore we are going to expect a boron and its compounds to be displaying unique characteristics. And of course, in our last discussion, I mentioned that boron, whenever it's going to be forming compounds, especially its halides, is going to be displaying, of course, a unique case. And we had compared two specific, of course, cases for the halides of boron, whereby we are seeing these two specific molecules. And I'd say that basically the first molecule has not been isolated as a stable compound, whereas the second one is the simplest member of the hydrides, which has been isolated as a stable compound. And we had compared this one with a member of the alkyne series, which we had looked at in terms of their Lewis structure. And I've mentioned that basically in trying to contrast these specific two members, we're going to see that due to the deficiency of electrons around its central atom, this is going to form a structure that is going to encompass what we refer to as 3 center 2 electron kind of a bond. And this bond is basically a bridge that is going to connect 3 atoms using 2 electrons in this specific case. Now, they've basically given a structure for this particular compound and say that basically in this formation of this particular compound, we're going to have the boron central atoms being given as such, and we're going to have a bridge that is going to be formed by these 3 center 2 electrons given as such. And we're going to see some of the members as well as aluminium in terms of their halides and try to contrast it with this specific member. Now, this is one of the unique properties of a boron, which is going to be displayed in terms of its compounds, especially if we try to consider the formation of compounds of boron given as such. And as I've said, this is going to be the case due to lack of the octets of electrons about the central atom, and therefore it's going to be giving it one of the characteristics. Now, this is going to form a weak Lewis acids, and of course we're going to look at one of the examples of the compounds as well, additional compounds, which is going to form a weak acid, which is basically also a compound of carbon, compound of boron, sorry for that, given as such. So in this case, we shall look at the specific sources and applications of boron, as I had mentioned. And of course, this is going to be given in various aspects in terms of distribution. Now, in our last discussion, I said that basically a quarter of the elements in the periodic table are going to be found in their pure form, while the rest are going to be found in terms of ores or perhaps in combination with other elements in their natural sources. Now, the compound or the compounds of boron are found concentrated as ores, as I said. And these are found in various geographical regions. We can just mention a few. These are found in Tibet, and also we can find some in Russia, Italy, and then we're going to see that the Californian desert, among other areas which we are going to see. Now, in this specific case, then therefore we're going to see that these specific ores have to be processed in order to obtain various compounds. But of this, the most common one is going to be this specific, of course, a compound which we are going to see being the most abundant of all these combination of elements which are going to be compounds of boron. Now, we are going to also see that the process of crystallization is going to be very essential in trying to separate this specific or processing of this specific ores of boron. And this is one of the methods which is going to be exploited in trying to separate these specific ores from their, of course, from other impurities. Now, I mentioned that apart from this specific method of crystallization, there are various other methods which are going to be used in processing ores in order to obtain either compounds or elements or their compounds from various sources, as we are going to see later. Now, these methods include electrolysis, reduction, fractional distillation, and even liquefaction of these specific components that I've mentioned. Now, I've said that apart from these various sources which we're going to see having these particular compounds of boron, there are various applications which are going to be, of course, areas of course, use for various compounds that we are going to come across for the compounds of boron. Now, one of the examples that we can give for this is sodium borate. And of course, this is going to be one of the compounds which is going to find wide application, especially in the bleaching or manufacture of bleaching agents in the detergent industry, or the soap and detergent industry. And if we try to look at this, of course, I can just have a formula of this one. So we're going to have this one given as such, and then we shall have the OH group. It's going to be 4. Then we shall have that one with 6 molecules of water given us. So this is going to be a complex, of course, a salt. And in this particular case, as I've mentioned, it is going to be used in the bleaching agents. Now, in these bleaching agents, these are going to be the case due to the availability of this peroxide group, which I'm just encircling at this specific point. So the peroxide group is going to provide these bleaching capabilities in this particular salt. And as we had said, of course, we can just look at this isolated ion, complex ion, in terms of perhaps its structure, so that we are going to appreciate its specific stereochemistry. So in this case, as we are going to look at in our various videos, in case we mention them, of course, I'll be giving a reference to this particular video so that we can just create a contrast with other compounds. So in this case, for the 2 boron atoms, we're going to see these ones, the peroxyl groups bonding to them using this specific arrangement. And we shall have these hydroxyl groups, of course, appearing at this specific point and using this particular illustration. So we shall have this one given at this specific point as such. So this is going to form this complex ion, and we shall have this one given as a negative 2 negative given as such. So this is one of the ways in which we are going to see these specific compounds of boron displaying various properties. And as I've said, the bleaching capability is due to the presence of this peroxyl ion given as such. Now, another compound which we are going to see being essential in our day-to-day application is of course, boric acid. And boric acid, as we had, of course, come across it in some of our videos, mentioned that it's going to be one of the insecticides that we're going to come across in our domestic use, especially in trying to tame cockroaches and other, of course, household, perhaps, insects. So in this specific case, then, therefore, we're going to see that the compounds of boron are going to find wide applications. And as we are going to see later, I mentioned about this bleaching agent. Now, one of the properties of boric acid is that this is going to be a weak acid, which is, of course, going to undergo what we refer to as self-ionization to form a complex. And this is one of the properties which we are going to see being displayed by the compounds of boron. So I'm going to give this one as perhaps another illustration. So we're going to have this boric acid being a weak acid, undergoing a self-ionization to form, so it's going to be hydrosonium ion plus, of course, we're going to have this one, boron OH4, and we're going to have this one given as such. So this is going to undergo self-ionization to form that specific complex ion, and of course, we can just have this specific state given as such. This is one of the unique properties of one of the compounds of boron that we refer to as boric acid. Now, there are other various applications which we are going to come across concerning boron and its compounds, and perhaps I can just mention them in this specific case. So they are going to be used in manufacture of adhesives, disinfectants, and of course in the dye industry, some of them are going to be used in manufacture of fertilizer and of course herbicides, among others. So these are going to be a wide range of application for boron and its compounds. Perhaps in closing statement, I can give a schematic a diagram for particular reactions which are going to be realized perhaps in obtaining boron and some of its compounds using this specific salt which we had mentioned basically as a common one. So we had said that this specific salt is going to be a common one, so we are going to have B407 and 10 molecules of water given as such. So if we expose this specific compound to sulfuric acid, we're going to form a boric acid, and that is going to be also one of the derivatives or the compounds that we're going to obtain from this specific course of salt through that reaction. So if this specific acid is heated, so we're going to see that it's going to form an oxide given as such. And if this oxide is exposed to heat under carbon, or reacting with the chlorine under carbon, this is going to form what we refer to as a halide. So we're going to have that specific halide being formed as such. And then if we react this one with calcium fluoride and of course under sulfuric acid, we're going to have that one forming also another fluoride being given as such, which is a halide. And then this one, if it's heated under magnesium, we're going to see that this is going to reduce into a boron, which is an element which I've mentioned. So these are various schemes which we are going to use of various reactions in order to obtain this particular compound. So if this one undergoes hydrogenation, it's going to undergo a reduction process in order to form that specific element of carbon. And this compound which I've mentioned, which is of course as a symbol, the simplest stable compound which has been isolated. Now we can obtain that compound from its chloride of boron by reacting it with lithium aluminium hydride. So this is going to form this specific compound which has mentioned and contrasted with the group 2 or the second member of the alkane series in our last discussion. So this is a simple schematic reaction diagram which is going to assist us, of course, appreciate various forms of boron and its compounds and some of the applications which I've mentioned in this specific video. So kindly check our description boxes for various links of other videos, and also be engaging us in the comment section and subscribe to our channel so that you can be getting various updates on the uploads that we do in mathematics and sciences. So that is it for now, guys. Bye, God bless. We'll catch us in our next video.